Good afternoon, everyone. Just like to welcome you to our Glencore Technology webinar for the Albion process on treating refractory gold. Obviously, you've had a bit of a time to go through the screen, but please feel free to use the Q&A button on the bottom of the screen to ask questions at any time, and then we'll look to answer those questions over the next a week, and then send out the answers probably with the along with the presentation recording that we're doing for you today. Basically, if you do have any major sort of urgent technical issues, you can try and use the raise the hand button and we'll see if we can help you out. But hopefully that won't be happening today. So today for the Albion process team, we've got myself, I'm Paul Bullock, I'm the principal metallurgist working here. And I'll be talking initially just about some of the engineering processes and the design of the Albion process and the plants that we will look to build. Then we're going to have Kelvin Roach, one of our senior metallurgists, come in and discuss the online calculator and where we're trying to really assist people get some information early and help make good financial decisions about their projects. And then Sarah Dowling, another of our senior metallurgists, is going to come and talk about the test work requirements and what you need to do to develop your project. So I guess starting in, so what is the Albion process? So really, when we're looking at the Albion process, it's a combination of two key things. One is the ultrafine grinding of the mineral particles, and then the oxidative leaching at atmospheric pressure. So to do that, for the ultrafine grinding phase, we're looking at using our Glencore Technology isomill. So it's a horizontal stirred mill using high intensity grinding. What this does is gives us a really nice tight size distribution. So that means that we have really good characteristics for leaching in the second phase. In our oxidative leaching phase, Glencore Technology has designed a leach reactor so that we can then ensure that we control the oxidation process very efficiently to really design the whole reactor and supply the whole package so that we can then give you the combination of the two pieces of kit, really to give you the plant that you need. I guess so. From that, really in refractory gold, obviously we're looking at generally pyrite and arsenic pyrite concentrates. So really unlocking the gold inside those pyrites so that we can then recover them in downstream processes such as CIL. Also in the Albion process, if you do have base metals that are associated with the gold, we can look at using our acid Albion process under different conditions, so we can actually liberate the base metals initially, and then still look to recover the gold from the tailings. So I guess, what do we look at to develop the Albion process for your project? So initially, you go through, you've done some drill holes and really get some cores, and you'll find that you've got managed to find some gold, and really looking at then, is that gold recoverable by typical cyanide leaching, or is it refractory? So obviously we're concentrating on the refractory gold and trying to assist with recovering that. So then what then constitutes the value of that? So really we're looking at how much gold is in there compared to how much sulfide that we would then need to oxidize to be able to recover that gold and give you the value. So obviously if there's the gold to sulfide ratio is really low, then perhaps there's an opportunity to be able to upgrade the concentrate using flotation. And Glencore Technology has their Jamison cell, which is really great efficiency at flotation to do this, and can supply either your single cells or a full concentrator. So really into the Albion, we're looking at a minimum of 10% sulfide. So what this does is allow the oxidative leach to run autothermally, and then for us to get maximum benefit and good recovery. So really, for us to evaluate your project, generally, if you get in contact with Glencore Technology, we can send you the Albion Process data sheet. So from that, we're looking for those key pieces of information, which is obviously the gold grades, the sulfide grades, and there's much other mineralogy that you can give us so that we can really get an idea of what is in your ore body. So from this, we can then basically assess what we would think would be a typical grind energy from our database for the IsaMill, and use some typical rate constants and resonance times for our oxidative leach circuit, so that we can give you a really high level capital cost and operating cost for that. So you can do those early financial assessments to see if you've got a significant value in your project. Basically, one of the other things that we're working in that space is Kel is going to come on a bit later and talk about our online calculator, which is really looking at this upfront value add, so you can find out if your project is really going to generate the revenue and the profitability for you. So really, the next phase that we'd look at is actually doing the amenability option. So really there, it's a one simple test, which is a fast fail yes or no to say that the Albion process will work for you at a given set of conditions based on that feed mineralogy that you would send to us. So we would pick what we would think would be the most likely conditions and a long enough residence time to allow that to work. And that can then give us, I guess, that confidence that we know that the Albion process is going to be able to assist you in upgrading your gold recovery for that refractory ore. From that, we would look to do a sort of class 5 desktop study, which is a plus or minus 45% accuracy. So from that, once again, we would be using, I guess, just the data that we get from that test work and our database for the IsaMill for the grinding, but then using the test work, I guess, plus our judgment to pick the conditions to design the plant to give you that sort of accuracy. Moving forward, I guess, really it depends on your company and your whole capital management framework and really what you require to progress your projects. So for that, I guess we're really flexible and we really want to work with you to be able to develop the right way and really ensure that your project goes forward and meets your requirements. But I guess if it follows a typical pathway, then the next stage is really the PFS or a class 4 engineering study. So from that, I guess what we do is we do, I guess, a step up in test work so that we can actually get a really good understanding of the sizing of the project for both the IsaMill and the Albion leach process. So really, that involves then basically signature plot and kinetic test work that Sarah will take you through the details of later. And from that, realistically, then we're at a stage where we can guarantee our design for scale up from the bench scale to the full scale operation, and can offer process guarantees on that test work. So I guess that's really what drives the fact that we can really get the accuracy down for our PFS. And basically for that CapEx and OpEx, we can either look at obviously supplying those package prices just into your engineering company if you're using one, or really looking at a full process CapEx and using for the whole of the Albion process. And we can actually talk to other members of our team to look at the flotation side as well if that's required. And then basically moving into the next phase, if you're then taking it up to like the feasibility study or definitive feasibility study phase or class 3. So what that means for us is really, as far as the testing goes, it's looking for the testing to go further into the downstream testing. So a lot of the thickening and filtration work, as well as the CIL optimization, if that's where it's going, and using the vendor testing at that stage for thickening and filtration. Basically, and also looking at variability of your ore body and doing, I guess, multiple tests just to ensure that really you know what's going to be happening for the first few years of your project, and you can get that that accuracy into that and the understanding of your mine. For that, I guess, yeah, we don't need to do a pilot plant to be able to give you the process guarantees. We can do that from the bench style test work. But obviously, if you need the pilot plant work to be able to work through your own project requirements, then we can definitely assist with that through some of our accredited labs also. So yeah, so from that really, coming out of that, really for our technology, at that DFS phase is a proposal for a package plant, obviously for the isomill and also for our leach reactors. And then we can also work either to develop the full plant design. We're actually using our mechanical engineering team to do data sheets and go out for pricing and then consolidating all that together. Or we can work with your engineering company and just do the Albion specific and pass on the process design information to them for them to work through that. And that's really our main aim, is to really work with you to manage the requirements of the project and to fit that in. I think from that, I'd now like to hand over to Kel to, oh, sorry, I missed one. That's right, I guess in the execution phase, obviously, really, was what I talked about, the flexible design support. So really the Albion package of the oxidative leach reactors and the isomill package. Obviously, we also then look to come to site for construction and commissioning support. I guess in between that too, depending on the supply, we can also look at, just doing that front end process design to help to assist to size the other parts around the plant and to supply that information into your engineering team to do that execution and construction work. So yeah, now I'd just like to pass on to Kel, who's going to take us through the online calculator. It's in development. Thank you.
Thanks for that, Paul. So now that Paul's gone through the different steps, I'm going to show you a step 0, as we like to call it. So this is our online calculator, specifically looking at the refractory gold Albion plant. This is not currently live on our website, so as much as I'd love you to, don't run onto our website right this second to try and find it, because it's not there, but it will go live very soon. We will obviously send that out on LinkedIn, etc., when that happens. So what is the online calculator? So the whole idea of this is it's completely free. You get an order of magnitude CapEx, a mechanical equipment list, an order of magnitude OpEx, rough staffing requirements, power requirements, and the oxygen and reagent requirements of a refractory gold Albion plant completely for free online at the touch of your fingertips whenever you desire it. So these are work in progress images. This is from the mobile version. So there is also a desktop version, as you'd expect. So the only information you need to give us is your feed rate in concentrate tons per annum, your gold grade, and your sulfur grade. That's the only information you need to actually know in order to get all that information from us for free. So you then would simply jump on, you say roughly, this is what my feed rate is, how many grams per ton gold I have, and what my sulfur grade is. Ideally, you'll know all this by already. You can then give us all the other information if it's a polymetallic ore body. As Paul was saying, if there's some copper in there, if there's some iron in there. If you don't need to know this information, but it will help. All right, so the next one, these are your operating costs. If you know your operating costs, punch these in here. That'll give us a lot more information. It'll give us a lot more accurate OpEx cost for the Albion. If you don't know them, or you don't want to tell us for whatever reason, those numbers that you see on the screen will already be populated, and we've used them as our sort of default based on our experience of what you'd expect to pay. Then you just tell us who you are, what your email address is. That's simply just to get the report, and you will need actually to give us that. So what do you get? You will get this very funky report full of lots of really interesting information, again, all for free. So it'll tell you what your direct costs are for the materials, your commissioned costs, and your OpEx, all in US dollars. Then that will include our MEL, So mechanical equipment list in all the different materials and all the different equipment that you will get as part of your Albion plan. It'll then tell you all the different factors that we've included so that you can then talk to us and say, hey, in my part of the world, I think that's wrong, or I need to adjust that, etc., etc. You'll then get an OpEx that will tell you your power costs, your limestone costs, lock-in costs, labor, all those things that you've given us or that we've put in for you. That'll then tell you all your reagent usage, your how many employees, your factors, everything that you need to know to then look at the Albion process for free in your own time and say, is this something that I want to look at further? Is this something that will work for me, will work for my project economically? That then forms the basis of the conversation between us and yourselves when you come to us and say, I'm looking at the Albion process, I would like to know more. So, short and sweet for me. I'm going to pass over to Sarah now to go through the stages of test work.
Thanks, Cal. All right. I'll be going through, not that. I'll be going through our test work phases with you. And really, this is a journey that accompanies our engineering studies. At the different phases of the engineering studies, we recommend that you look at the test work in different levels of detail. And I'll say at the outset that we deal with 3 accredited labs. So we deal with these labs because we want to ensure that the tests are conducted correctly and we can trust the results and we can use these results for process guarantees. So to jump into the phases, the first phase is, which usually accompanies a class 5 or concept level study, is an amenability test. The objective here is to work out whether the Albion process is amenable to your ore. The test is designed to be fail fast. And by that, I mean we remove all barriers such as grind size and residence time. It stops you, the client, from wasting time on a process which might not be suitable for your ore. So we run this test at a grind size of 8 microns and 72 hours. If the test does fail, and by fail, I mean you do not get a good gold recovery and on the Albion leach residue CIL test, then we'll know that there's something in the properties of your ore that does not make it amenable to Albion process. An example of this could be that the gold is actually not hosted in sulfides, and therefore the Albion process does not open the sulfide matrix and make the ore more amenable to CIL. Then we step into the phase 2. Now, phase 2 of the test work usually accompanies a class 4 or pre-feasibility level engineering study. In this phase, we are looking at the practicalities of the milling portion of the Albion process. We look at the grind sensitivity and the isomol sig plots. The grind sensitivity tests are conducted at 3 different grind sizes. Ideally, we conduct these grind sizes, ideally the grind sizes are higher than 8 microns. We can do this if the sample that you've provided us in phase 2 is the same as the phase 1 sample. What we are looking for in this grind size sensitivity test work is what is the maximum grind size where the gold recovery is still high. And hand in hand with this grind size sensitivity test work, we look at the signature plot. Here, we are working out what the specific energy is for the isomol. Now, it's important to note that an increase in as little as 2 microns can result in very significant cost savings in energy on the milling side. This is the reason we do this phase of the test work. Moving on to phase 3. Phase 3 of our test work normally accompanies a class 3 level study or a feasibility study. Here, we are looking more at the practicalities of the leaching portion of the Albion process. To this end, we do 3 so-called SOX variability tests. By SOX, I mean sulfide oxidation. In that initial amenability test, the extent of sulfide oxidation after 72 hours would have been probably more than 80%. And normally, you don't actually need 80% of sulfide oxidation to open up that sulfide matrix. So in this phase, we are looking at different residence times with therefore different sulfide oxidation extents to work out what the minimum is that will still give you good gold recovery in the CIL subsequent to the Albion process. With the SOX variability test, we also then look at the density sensitivity. In the amenability test, we ran the test at 15% solids. There is always potential to run the test at maybe 30 or even higher percentage solids, which will reduce the size of reactors and reduce the capital expenditure for you. Lastly, we're looking at generating a bulk leach sample. This is to be used for settling and thickening infiltration and to work out very important engineering parameters such as settling rates, flux rates, and we even target enough sample to do rheology testing to work out key pumpability parameters. All of those parameters that I've mentioned will feed into the Class 3 engineering study. Lastly, the phase 4 is really very project dependent. If the same sample has been supplied throughout these phases, often you don't need a phase 4. However, if the project has changed, the area you're looking in has changed, or something has changed in the sample, some of the SIG plots, the grind sensitivity, and the SOX variability would need to be repeated, and it will be done here. Ideally, this phase 4 of the test work should be done before the Class 3 engineering study. This is because there's quite a big jump in cost between a Class 4 engineering study and a Class 3 engineering study. So really, you want the best inputs to the Class 3 engineering study to save on costs. So now that I've talked you through this journey, some immediate questions jump into mind. For example, can different phases be combined? What is the duration of each phase? What is the cost? How much sample do you need? So often, as Paul and Cal alluded to, a Class 3 often goes straight from Class 3 engineering level to, from Class 5 to Class 3 engineering. This means that you can jump from an amenability test to a combined phase 2, phase 3 test work program. However, the phases can't actually be skipped. This is because the phase 2 looks at the grinding section of the Albion process, and the phase 3 looks at the leaching portion. So ultimately, all phases would need to be conducted. If a combined phase 2 and phase 3 test work program is being done, it would be very important to ensure that the sample provided is representative of the life of mine or the life of the project. One of the benefits of splitting up the phase 2 and the phase 3 is that you get an even spread of expenditure for your test work. In terms of the duration, so a class 1 or phase 1 or an amenability level test from when we receive the sample to when we issue the test work report is of the order of about 6 weeks. For phase 2, this can increase to about 3 weeks, and phase 3, we're looking at about 26 weeks. Now to move on to cost. So every project is very different, and each project has different levels of complexity. So I'll give you a cost range. So as we see on the screen, phase 1 ranges from $23,000 to $30,000 US. Phase 2 ranges from $30,000 to $90,000 US. And phase 3 jumps to $150 to $250 US. When you look at what's included, we've put the test work conclusions here. So this is there for you to take home and consider more deeply. I will now pass on to Paul, who will go through a 3D model. Thanks.
Thank you, Sarah. So yeah, I guess we just wanted to sort of walk you through one of our example 3D models that's been taken from our Class 3, so feasibility study engineering. So really the capabilities that we have here at Glencore Technology to support you on your projects. So obviously we have a very strong process team whom all of us are working as, and we also have very strong mechanical and drafting capabilities. Basically, we use a partner for electrical and instrumentation type services, And to do that is what helps to put together our Albion process designs. So this was for obviously it's for a gold project, but this particular gold project also had associated base metals. So therefore that increases the complexity of the project and also of the plant, because then we're looking to take those base metals into solution and then to actually produce them as intermediate hydroxide products, so that we can then filter them off and they can sell those, as well as then recovering the gold in the downstream portion. So skipping forward to the photo, I guess, so really here we can see the isomill at the front of the plant. So for that, obviously from what Sarah was saying, we had to do the signature plot, which basically gives you the kilowatt hours per ton that you need for that ore. So obviously the grind sensitivity, as Sarah says, is very important because it's an exponential curve on as you go down in size versus the actual energy. Really looking at that optimum position. If you can keep that energy requirement down, obviously you can run through the isomill as a single pass, due to the really good sort of classification that happens internal to the isomill. If it is a high energy demand, then we actually will have to run in closed circuit with cyclones, as is in this plant. So basically running as a typical classification circuit around the isomill. The isomill, obviously, there's a very large range of sizes from the M1000 to M20,000. So really we're looking at up to 5 megawatts of power per mill. So a very good range of throughputs that we can do through a single isomill. So then from the isomill, basically we go into a concentrate feed tank, which is feeding into the first 3 of the Albion process tanks. This allows you to bypass the first tank if there's an issue, and still maintain the operating circuit. So for this, we have 6 tanks that are running under acid Albion conditions to liberate the base metals. So that's basically running at a free acid of about 10 or 15 gram per litre and allowing them to come out. And then basically straight from there, it's going into 3 iron neutralisation tanks. So lifting the pH up to 3.5 to drop out the iron and aluminium prior to going to solid liquid separation. So then taking the PLS out for our base metals, and then taking the residue from that and taking it forward. Basically, we're going here actually into a lime boil in this circuit using another Albion leach reactor, so elevating the pH up to pH 10 to run the lime boil, because it found that it was, in this case, it assisted in the gold recovery downstream. And guess it also, obviously, because it's already elevated the pH, saves those costs down in the gold plant, and it was also a reduction in cyanide for that. So I guess that solid liquid separation happens first by thickening, and then basically running these two belt filters there to get that wash efficiency to ensure that we're not losing any of those base metals. I think if we move forward, that's just the view from the other end of the plant. So obviously, so down in this part of the plant here, we have there's two base metals recovery circuits. So what they entail is a number of precipitation reactors. So here we're precipitating out with the lime to make a hydroxide, and then going through thickening and filtration to make a filtered powder product that they can then bag and sell. I guess just a close-up view of the Albion leach reactor. So basically here at GT, we've developed a number of standard sized leach reactors that run from a live volume of approximately 200 meters cubed up to 2,600 meters cubed. So that means really that we have this information. So when you come to us, that we can get really accurate pricing and a really good understanding of what is required inside that reactor for not only just for our studies and to give good pricing in that, but then also down to actually give accurate pricing coming into our proposals at both the sort of fixed and at the fixed end. Obviously, we would go out to price on our subcontractors, but it maintains really accurate pricing for our studies. Obviously, the key part for our leach reactor design comes down to, we've done the test work, We've done the kinetic work, so therefore we can actually work out the mineral rate constant because the leach reactor is designed such that the agitator input power to ensure that the oxygen diffusion is not limiting the leaching of the mineral, along with the power that's inserted through our oxygen sparge, the hypersparge. So therefore we can get that rate constant, which typically for pyrite and chalcopyrite is a first order rate constant. And from that, we can put that into our models, and using a CSTR to get a very accurate model of the leach reactors, and working out obviously the resonance times and the heat and the mass balance to do that sizing, and to be able to then obviously scale up from the bench scale test work for this design. So I guess so really that's the Albion process. I hope that you got some good information out of that. Obviously, if you're interested in finding out more about the Albion process, or really want to review one of your projects to look for value and really upgrading that gold recovery in your refractory ores, please definitely contact us at the Albion process at Glencore, and yeah, we'd be happy to talk to you at any time.